Our next speaker is John Mailhot, who is the CTO and Director of Product Management for Imagine Communications. And John is going to be talking about something that is super important and often overlooked in 2110 systems, and that's how to manage audio in many different ways, particularly mono audio. So, take it away, John.
Hi, I'm John Mailhot. Take a seat. It's going to be fun. This is kind of like a talk about the third rail here, if you're familiar with subways that are electric and they have the rail that you can't step on. And that would be audio. So, it's a simple question. Why is audio always the problem, right? If you think about every time we stand up a system, well, the video's working like on the first day, right? Because the video standards are really regimented and people put a lot of effort into how they implement everything, and there's been a lot of interrupt events over the years. And the main reason the video is always easy is because there's one of it. And so that makes it go pretty well. Now, audio is the problem because no two facilities use audio the same way, right? Playout centers tend to organize the audio channels into mixes that, travel together. But a production center, you might have a camera out in the dugout that has a reporter microphone plugged into it, but the reporter is really being shot by another camera, right? And so in the production, that audio isn't really related to that video. It's just transported. So production environments, you need to get the right audio kind of in some manual way because every show is different. Well, that's two different systems, and yet even in a simple quote-unquote environment like a playout system, people still want the ability to go to a, like a router-like control interface and fix something, patch a channel because it wasn't right, or patch, some other audio, or do a voiceover, those sort of things. Well, IP didn't make this headache. This headache has been with us in the television industry for pretty much as long as we've had embedded audio. And with embedded audio, the video routers would disembed the audio. You'd have a TDM matrix inside the router. It would re-embed. You could do mono breakaway. It was expensive compared to a simple cross-connect, but at least you could do it. You could buy the parts and make it happen. But in IP, well, let's talk about IP because that's what this talk's about. The audio problem in IP is that for a variety of good reasons, the audio is organized into these streams, and streams usually have multiple channels inside. And so NMOS, ISO 4, it lists all those streams, and ISO 5 provides a way to connect those streams to stream receivers, and it all works. And that part works great. But if you want to take the left channel from that stream and stick it here, well, there's nothing in NMOS that describes that exactly. And so shuffling, substitutions, wild mapping, how do you do that? Well, that's why we're here. In the AMWA, we developed ISO 8. So, everyone knows about ISO 4 and ISO 5, and they do their thing well. ISO 8 is a API that describes what happens after the receivers. So the receivers, the channels come out of them, and they go into, in most devices, some kind of audio matrix where you have some amount of routability. And ISO 8 provides an API to manage that matrix inside the device. So if the control system wants to, it can treat the receivers like a pool of receivers and take a channel from here and a channel from there and do the right thing. And this all sounds great, right? And ISO 8 also could be used on the other end, marshalling channels into senders, although that's less common. But on the receive side, it all sounds like a great scheme. You say, well, it's a control API and a control system could use it to do that. And that's true. But there's another way too. You could make every mono channel its own separate multicast. And we've had customers try that. It's got a different problem, right? It just creates this explosion of the number of multicast groups, right? Because you start having like 16 audio multicasts for every video, and it just blows up the size and complication level of the whole system. It can work, but the other problem is a lot of devices don't have that many receivers. There seemed to have been an idea in some of the audio products that, like maybe 4 receivers for 16 channels, that kind of ratio. And that's just not necessarily a good number, no matter how you're going to slice it. So, the other thing is if you even had enough receivers, switching every one of them separately creates a whole set of transactional things that are just time consuming in the control system. So it'll create a little bit of switching lag, and that's a different problem that no one wants. So what does stream routing get you? Well, in a facility that's organized into streams, you can do like an audio follows video take, and the audio, the video stream, the audio streams, they all follow together. And if you route them to here, they all go. If you route them to there, they all go. That's the normal case, and that works great. You can also do breakaways at the stream level in most environments, where you can take, one video and different audio streams. That works fine too, because that's all just ISO 4, ISO 5, stream switching. Most control systems, it's called an audio breakaway. We all support it. But what happens if you have some other feed where the audio is completely organized wrong? The first thing most people do is inside this gateway or inside the receiver itself, they'll shuffle the channels there so that the streams are correct, and then they can just do audio follows video stream routing. That's the most people do that kind of case. But it still doesn't give you what operationally the ops team says they want, which is the ability to walk up to a control panel and say, I want to put that channel there. So how do we get there as an industry? Well, the key is somehow to combine the ideas of stream routing and track routing, because the streams route to stream receivers, and then most devices have some kind of audio matrix inside, and the destination in a routing system kind of way of thinking about it, the destinations are really these channels. So you want to create a routing environment where the user can say, I want to take this channel from inside here and route it to this place over there. So the key is, how do you, the way the user would like to think about the route is to say, I want to take this channel from inside here and I want to route it to this place over here deep inside the device. And, the controller can manage the receivers using ISO 5, right? So the controller can send streams to the receivers. And then the key is that the controller can use ISO 8, remember ISO 8, to control this map. And with the combination of those two, you can model what the user actually wants, which is to be able to take the channel from in here and route it to the spot over there. So, well, that all sounds good. And operationally, you could wild map it, right? You could just, for these things, do take those two things in and do your crazy quilt map that makes sense operationally, because you know what those channels are, because you just got the list from the truck 5 minutes before air of what's on which audio channel. And this happens in reality, right? That 5 minutes before air, the truck says, hey, no, the audio is really this other way. So having a way to deal with it is an operational imperative. Well, what's the problem with all this? Did we really need ISO 8? Yeah. I mean, there's no public API for how to manage that map inside devices. And if we have one, then control systems can build to it. And if we don't have one, then we have to write a driver for every different device. And customers don't like buying drivers, and we don't like writing drivers. So it's a happy solution. But, ISO 8, the good news is it exists. It's been published now for 2 years. It was actually talked about widely at the last NAB that there was, if you remember back 100 years ago. But what's the reality? Well, the reality is that there's a lot of devices that don't support ISO 8, and there's some that do. So for devices that do, you can use it. You can build a hybrid case, basically, where for devices that support ISO 8, the control system can use it to manage routes all the way from, at the audio mono level, and that works. But the challenge really is, what if the user really wants to do that mono patchboarding? Well, for devices that support ISO 8, obviously it can work the way we just talked about. For devices that don't support ISO 8, you wind up needing a helper matrix. And you'll see this in 2110 deployments from us, from Grass, from Evertz. Everybody kind of takes this approach that there's basically an audio helper matrix that's doing the job externally because there's not a good way to do it internally inside the receiver. And so that's how, as an industry, we're attacking this problem right now, is by saying, well, you need a helper matrix to clean up for the devices where you either don't have an API or don't have a driver. And then for devices where you do have an API driver, like ISO 8 or some other API driver, then you can do the first approach, where the control system just uses the stream receivers on the device and sets the map directly. So going forward, until the whole world has drivers, which could be never, I think this hybrid approach of a mix of ISO 8 support and some kind of helper matrix is what's going to rule the day. And that seems to be bearing out in practice in every device, every project we see. And over time, the helper matrices will wind up being smaller because more devices support routing directly. But right now, the good news is, in the audio world, people are making bigger and bigger matrices for more and more reasonable price points. And that's a trend I hope continues, because we're kind of intersecting between ISO 8 adoption and the need for helper matrices. So I'm glad that the audio vendors are building bigger and bigger matrices to support these kind of architectures. So what's the state of ISO 8, right? Well, the spec was approved years ago, and it works, and it's been used in interops, and there are devices that support it. Just not a huge number of them, but it's coming. It's getting out there. And in the meantime, we use this hybrid method to get the job done. So that's my story. Are there any questions about that? I see we've picked up a lot of people as we've gone. Sir, you're going to ask a good question.
Hey, John, so is the helper matrix a physical device or a virtualized implementation?
The helper matrix is a real thing. Something's got to do something. So in our projects, we tend to get them from one of the usual audio suspects. A little bit depends on which market. In our projects, often we'll either partner with CalRec or StageTech, depending on the region and the customer preference. But Grass has a matrix of some sort. I'm sure Lavo uses a Lavo matrix. Evertz has something. This is a similar approach taken by each of us. Just we have each different alliances on hardware.
So I just want to follow up on that. Conceptually, could that be done virtually inside some sort of, just basic IP processing device?
Sure. I mean, that's what the audio matrices are fundamentally. If you take one apart, it's a whole bunch of receivers and a matrix and a whole bunch of senders, and it may or may not have reclockers and other accoutrements. But you could build it in software. Nothing stops you from doing it that way. Doesn't tend to be the design pattern I see, but if somebody made a nice software one, it would be certainly applicable. But I think the funny thing to watch is the adoption curve of, as more devices pick up the API, either ISO 8 or some other usable API, the need for those matrices will diminish, but it probably won't go to zero, because there's going to be endpoints that only speak one stream of 16 channels, right, or 2 streams of 8, and that's all they know how to do. And so if you want to use them in a system that's mono-patchable, then you're going to have to clean up for it somehow. So I don't think they'll go to zero, and I think they'll go up before they go down.
All right, John, thank you very much.